Hey, welcome to the first devlog of Untitled Gravity game, name pending, and the first game I ever worked on. Which, if you've seen my real-time Pokemon video, this is the predecessor. The first attempt at this game was back in 2016, but because of its complexity and my inexperience, I decided to place it on the back burner. And in 2020, though I still didn't have the technical knowledge, I came across two free plugins that handled most of what I needed to get started. Those plugins being the Ninja Character and the Spider Navigation. For the Ninja Character plugin, honestly there wasn't much I had to do besides fixing the camera. As right from the start there were several different gravity types supported, and the movement felt like the standard Unreal Engine movement, which is to say great. But the smoothness of the camera relied on the map terrain being high poly, which I wasn't working with because I based the item spawner off of each face of the map terrain, and if I increased the poly count, I would have possibly had to have dealt with multiple thousands of items being spawned, which this ended up being a blessing and a curse. A blessing because now I'm not restricted to a certain poly count minimum, but a curse because I found out that either Blender or Unreal Engine doesn't always store the two triangles used to make a square face in adjacent memory. So while the item spawning method works for the first map, it doesn't work for the second map. Which a simple solution to both the camera and the item spawner would have just been to have a high poly map and hand place all the pickup items, but let's say I'm stubborn and didn't want to hand place items. Also, I'm trying to write most of the systems to be drag and drop, hoping it will speed up future development times so I can try and make at least 50 maps quickly. Though I do want to make more, but after 5 I'm already running out of interesting map designs, so yeah. Which I didn't think of this at first in my blind stubbornness, but this should make porting the game to mobile quicker as all of the models are already simple enough. So all in all, the smooth camera result is exactly what I wanted, but I feel like I'd be doing you a disservice if I didn't tell you how long it took me to accomplish. It took about 2 to 3 months of research and a week of coding, but I've been tweaking it here and there, so let's just add another month. However, I have no experience in game cameras, so it may take you less time. And if I were to have used that time instead to work on multiple maps and placing items and improving the spider navigation plugin, I would probably have a more complete game. But hey, it works, right? Man, I need to get better about not being a perfectionist. The spider navigation, it was a good start, but there were several problems. Starting with the generated Navmesh being stored in a save file, which I learned you can't just give to other people. Uh, yeah, that was a rough lesson to learn. So anyone wanting to play the game would have had to generate the Navmesh on their computer, and being it took my 7700K CPU from 30 to 40 seconds and a bit over 3 gigabytes of RAM, I can't imagine most people would sit and wait for the Navmesh to generate just to play the game. That is to say, if their computer didn't crash from the RAM usage before completing. So I did the quickest fix I could, a file reader and writer using standard C++ because I didn't know much Unreal C++. And don't worry, the couple of Unreal devs that were watching made sure to flame me. But it worked, and that's all that mattered. Though the navmesh generation values I settled on again took 30 to 40 seconds, and using values that took longer than a minute to complete caused my editor to crash from running out of memory, and the values that took less than 30 seconds generated too many holes. So I guess you could say I was stuck between a hole and a crash place. Is that too much of a dad joke even though I don't have children? But with that, I decided to start working on optimizations because if you download the plugin from the public repo on GitHub, you'll notice there's an 8 nested for loop. However, surprisingly, that isn't the slowest part of the code. No, in fact, the slowest part was dividing the 3D bounding box into a bunch of points equally distanced from each other and spawning actors at each point. Then checking for mesh collisions in each of the 6 axis directions, so x equal to 1 or -1 and y and z equal to 0. Then repeated for the 2 other axes, which I don't remember if the raycasts were shorter than the distance between points, but regardless, there had to be a faster and more efficient way. And after asking around, one genius game dev had the idea of using multi-line traces in a grid pattern much like the equal distance points, but instead go from one side to the opposite of the bounding box. This gave me a good place to start, but I had a sneaking suspicion that for the multi-line traces, once the map was hit, it wouldn't register again. So I changed to single line traces, and after hit was registered, I would spawn a new trace until I got to the opposite side of the bounding box. Upon testing this, an unexpected feature appeared. When tracing from the outside of the map inward, the collision check didn't fire, so I thought maybe this was because the line trace was almost parallel with the normal of the plane it was intersecting with. However, when flipping the trace direction of the visualizer, the example planes work for both directions, so I'm a bit lost as to why that is. I'm thinking maybe because the maps were more complex, being there's multiple faces, maybe someone watching knows like, oh, you need to enable this one feature, or using the complex as a simple collision setting is the root cause. Regardless, the new method resulted in a similar output to the original, but with short 88 nav points, which results in a 4.4% error. However, this falls under the 5% scientific margin of error, so it's acceptable. Not that I really cared about following science class standards, but you're probably wondering, what are the running time differences? So I measured the time differences twice because the platform times seconds function that I used to return the execution time of the Navmesh build function returned a time of 0.09 seconds to one of the new method's runs. So I assumed it wasn't that accurate, plus I didn't record all the runs of both methods the first time through, so the runs I manage will be on the left side, and the new runs that use the chrono library will be on the right side. And I made sure to record all of them this time. So while we're watching all the runs, let's talk about the big numbers. The average of the first recording runs were for the unoptimized code 15.6 milliseconds per nav point, and 0.41 milliseconds per nav point for the optimized code, which is a 37.9 times speedup. For the chrono runs, the average of the unoptimized code was 16 milliseconds per nav point, and for the optimized code, it was 0.34 milliseconds per nav point, which results in a 47.8 times speedup. And some of you are probably thinking, you're only using the chrono runs because it gives you a better improvement. And to that I say, yeah, duh, why wouldn't I? But jokes aside, let's recall that during the chrono runs, OBS was recording the entire time. However, during the original runs, OBS was recording half the runs. So my CPU was doing less work during the unrecorded runs. So yeah, the lesson to be learned from all of this is don't use Unreal for calculating performance. Now for the memory comparisons. Running sequential runs doesn't yield the same difference in memory allocation between runs, which I believe is either because Unreal is keeping some memory reserve so that it can be used for later editor operations, or the code has a memory leak. But for the original run, the memory usage of the unoptimized version was 3.36 gigabytes and 140.5 megabytes for the optimized version, which is a difference of 23.94 times. For the chrono runs, the unoptimized version was 3.38 gigabytes and 136.6 megabytes, resulting in a difference of 24.75 times. But since the timing libraries used don't vary more than 5%, we can treat them as equals in this metric. So considerable improvements have been made to the point where I could probably remove the saving and loading parts of the code and have it generate at runtime. But the holes in the Navmesh still haven't been fixed, and increasing the number of spawn points or trying to make other parts of the algorithm even faster doesn't fix that. Especially after I spawned 11,000 nav points, which took 5 seconds and still had holes. And I didn't test a higher number because I imagined how bad this would run on mobile in both generation time and pathfinding. So this led me to the last thing I wanted to do, recreate Navmesh from scratch, especially after reading the creator's blog post and seeing all the clever techniques used. But I'm going to do this out of the necessity for a Navmesh solution that doesn't have gravity hard-coded to one direction, and my inability to fix the spider navigation plugin. So though I'm far less experienced, my idea of how to solve this is to load the walkable areas of my maps into Navmesh itself, since they are already low poly. However, I'm not fully sure if this is possible. But in the future, I was here going to quickly interject for a second. While making this video, I came across this blog post that talks about loading a mesh into Navmesh, so hopefully by next devlog I will have that implemented and an answer to if it works without resulting in a path that causes the AI to fly from one end of the map to the other. This, if it works, will result in a higher level of AI fidelity, as the AI will no longer go from nav point to nav point on a predefined line, but instead move directly towards the player. But back to what I was saying. But in the future, I'd like to come back to navmesh generation, but use sparse voxel octrees instead of the walkable meshes or 3D grids because they perform better with higher poly meshes and ensure no holes. Which most of this is what the recast section of Navmesh already does, but again, my inexperience and having a hard time following the code, so why not build the intuition by recreating it? Last, I would like to touch on the UI. I'm thinking of a 1980s neon aesthetic, but have fears that making the levels consistent with it will be too blinding, especially if I made the edges along the tops of the walls neon, or that the contrast between the areas with and without neon will mess with the player's perception and cause a pseudo FOV change depending on where they're looking. The reason for this concern is I might have already made 15 to 20,000 people watching the Moonjam version nauseous. Basically, I programmed the FOV to change from 90 to 60 as the orbs were being collected, and that caused some people to lose track of the horizon and others tunnel vision. So yeah, let's not make that mistake again. However, if anyone thinks there's more to it, please let me know, as some people were unable to pin down why they were getting sick, so if you want to make yourself sick, the link to the playthrough is in the description. That said, for the final game, the FOV won't change unless you go into the settings, which got onto a tangent, but I'm using the auto settings plugin as the base, and not much has been worked on because the Navmesh portion is the sink or swim part of the project. However, thank you for watching my first devlog, and I know the people that found me because of the Pokemon video I haven't posted in a bit, and I'm sorry for that. I got a bit busy with Moonjam and real life stuff like taxes, but I also fear I put too much effort into how I sound during voiceover instead of just putting content out. Though hopefully I don't sound as out of breath as I did when I recorded through Premiere, and that my pacing is more natural without the 30-minute video constraint. I've also thought about the idea of starting a blog so I can keep people more up to date, or maybe I should stop caring about how I sound to others and just crank out videos.